Hey guys, this is Mr. Gilbert recording your lecture for work and power for Monday. It is opening day. Hopefully you guys are sported your Reds gear for today and get a little wiffle ball in or toss in with your families. Today's lecture will be short. Again, it's work and power. There are guided notes below here as there have been on the other two lectures. As we get going here, I want to go over a couple of assignments. One, make sure if you haven't done so, it was posted on today, Thursday. It was posted for Friday, but some of you I know worked ahead. But make sure you've submitted the Google form, just checking in for attendance purposes. That's something the state's requiring us to do. So there's a Google form right below Friday. You can click on. You just go in and click, type your name, click Miss Mead or Mr. Gilbert, and then I think there's one or two other things you need to fill out. So just turn that in to let us know that you've been getting your assignments okay. As far as the Rube Goldberg project, that is due on 4/1 by the end of the day, by midnight. If you need more time or having trouble gathering materials, just reach out to Miss Mead or I and let us know. There is an alternative assignment, but we'd prefer you get the Rube Goldberg done. And if you need more time, if it's just a matter of time extension, we can get that done for you. Just reach out and let us know. Otherwise, let's do it midnight on 4/1. Most of you, I'm sure, are well on your way for that. The last bit of housekeeping before we move on, has to do with extra credit. So the third quarter ends today on Thursday, not Monday, but Thursday when I'm recording this, or Friday, tomorrow. But we have until 4/10 to post grades. That gives teachers time to catch up on missed work and things like that, because a lot of students' grades weren't where they wanted them to when we had to get dismissed from the building. So if you need extra credit for the third quarter, you can go into Infinite Campus and check your grades. If you need extra credit, Miss Mead and I have posted an extra credit assignment on my website. It's on the Friday materials. So on Friday, there's of this week, of what would be the first week of NTI, day 4, there's an extra credit assignment posted where you can go watch a documentary. It can be of your choice. You can get on Hulu, Netflix, Disney Plus, whatever, and get on and watch a documentary about science. Then you're to submit a response in the Google form there on the website. That extra credit assignment is to be at least 200 words. That's usually like 2 decent paragraphs or 3. But it's supposed to include a summary and then your response. And so some documentaries require a long response, such as like if you watch Blackfish or Bad Blood or something like that, there's kind of one-sided bias documentaries. Those will make more of a response come out sometimes. But if you're watching more of a nature documentary, something I really like, the Planet Earth 2 documentaries, and those would be more of like, I found this really interesting. I really enjoyed learning about this animal and this environment. I hadn't heard about this before, that kind of thing. So if I was going to make a suggestion, some of those available. I know it's on Prime. It was on Netflix. I don't know if it still is, but Planet Earth 2 is really good. There's an episode about cities, animals that live in cities. That's a good episode to watch if you're looking for something to do for that extra credit assignment. Again, that'll go on your third quarter grade as extra credit for those of you that maybe didn't have grades right where you wanted to when we left the building. Again, let me know if you have questions on that, but that is on NTI Day 4 Friday. That assignment's posted at the end of it for extra credit for third quarter. For today's notes, again, they'll be short. We're looking at work and power. So work is force over distance. We already defined that once. So work is a force over a distance. Let me get my pen out here. Work equals force times distance. Now, that work is going to be measured in joules. It's a J. Joules. Force will be measured in newtons. That's a pretty bad job on my part there. At work in joules, force in newtons, and distance in meters. So joules is Newton meters in this case. All right. So it's how much push or pull we have to do on an object to move it a certain distance. That shows us the work is done, which is really ultimately the amount of energy we use to move something. All right. Now, the next thing we're going to get to is power. Power is often defined. Power is the rate at which work is done. Power is the rate at which work is done. Sometimes you'll hear it defined as the amount of work done in 1 second. All right, so the rate at which work is done, or work in 1 second. It's how much work we get done in 1 second. All right, so that's power. Power is measured in watts, and this is really significantly annoying because we have a W again, so we have W for a couple things here, but as measured in watts. So just like you might hear a light bulb is so many watts, that's the same thing. That's the power of the light bulb. This is just mechanical power, how fast we're getting work done, measured in watts. All right, so how do we calculate that? Let me create some space here on my whiteboard. All right, so power in watts is equal to work divided by time. Power is work divided by time. So that is watts. I'm showing you the units now. Watts is equal to joules. That is what we're using for work or energy over time in seconds. Power in watts is equal to joules, the work or energy over the time. Right? It's a pretty simple equation, just a division equation. So again, remember that whatever work we put into a machine, we've already talked about simple machines. Whatever work we put into a machine, we put it is going to come out the other side. Now, when we talk about power, it's kind of how fast we're doing work. So, if you will, the amount of force required for you to go up the stairs. There's normally a lab we do over this, but obviously we're not in class to do this lab. But if you were to go up the stairs, the amount of force, the amount of newtons, or lifting your weight up from the first floor of SK to the third floor of SK takes a certain amount of force. Whether you run or walk up the stairs, the amount of force that it takes for you to do that is the same, and the distance you're going is the same. So the amount of weight you're lifting is the same, and the distance is the same. So your work doesn't change. It's a force over distance. However, your power does change. And so if you run up the stairs, this bottom number, the seconds, is less. All right, so that would be going down. So anytime the denominator goes down, the whole number goes up. All right, and so as we decrease our time, so as we go faster, the amount of power required increases. If we were to go slower, then our power decreases. All right, even though the force and work are the same. All right, so again, so things like running up the stairs requires more power than walking up the stairs, even though the amount of force and the distance are the same. Now, if you guys play sports, this is a really good analogy for you, because if you consider like the idea of powerlifting or off-season lifting in sports, you usually lift high weights and low reps. So you're doing the same amount of weight total, but less reps at a faster pace. That's called powerlifting. A lot of weight, few reps, quick time, right? Versus what we do in season weightlifting usually is more reps but less weight. So the total amount of weight you lift in that set is going to be the same, but it's less weight at a time, longer period. All right, so powerlifting is lifting a lot of weight really fast. It's a faster workout, but heavier weight. So hopefully that helps clarify it for some of you and how that works. All right, let me know if you guys have questions. That's all I have for today.